several power surges occurred inside the reactor. It led to a chain reaction of explosions powerful enough to blow off the steel and concrete lid. But when the machine started breaking down in the toxic atmosphere, groups of men were brought in to clear 100 tons of radioactive material from the area.
Every year, thousands of workers walk into places knowing something could go wrong. Chemical leaks, gas chambers, collapsed buildings, and even to bomb disposal sites. Even with protective suits, strict safety rules, accidents still happen. The suits reduce risk, but they do not remove danger. Why are we still sending humans into the rooms that are designed to harm them? Technologies have advanced, AI has improved, robotics exists. But when things become unpredictable, we still rely on human bodies. That contradiction stayed with me. I thought the solution was simple. Just automate everything. Industries already use robots in factories. Machines assemble cars so perfectly. So I tried building a fully autonomous robot. In a perfect lab setup, it worked well. But the moment I changed the lighting or slightly moved an object, the robot froze. It did not know what to do. It could not adapt. That is when I understood something important. You cannot code for chaos. The real emergencies are unpredictable. Dust blocks sensors, light changes, object falls, surface shifts, pure automation fails when the world stops being perfect. That failure changed my thinking. Instead of removing humans completely, what if I remove only the human body from danger, but keep the decision making? The human brain is still most adaptable system in chaotic environments. This robot is a basic version of the robot. Like whenever if we step into solving big things, we come up with the small steps. So as a part of the first step, we started with working with a small humanoid. For the larger scales, we will be increasing the size of the humanoid too. I decided to build an application using existing humanoid robot that could be controlled by human operator from a safe location. The robot would act as the human's physical presence, while the human stays protected. To build this properly, I divided the project into 3 phases. Each phase builds on the previous one. We are moving step by step from movement to intelligence to fully independence. In phase 1, I focused on movement. I built the system on ROS running on Raspberry Pi 5, which acted as the brain of the robot. Everything was written mainly in Python. The biggest challenge in phase 1 was understanding how to communicate with the servo controls. At one point, I was stuck for 3 days. The ROS nodes were not communicating correctly. The motors were not responding as expected. My mentor guided me in this, and I finally understood where the architecture mistake was. Once I fixed the node communication and corrected the function calls, everything started working smoothly. By the end of phase 1, the robot had a stable physical body. In phase 2, I focused on giving the robot the abilities to see and decide using camera. I built everything using a pub/sub architecture in ROS. I used OpenCV to process image and MediaPipe for gesture and hand tracking. Then I built human interaction pipeline in Python. The camera captures the image. The program successfully processes it, then uses conditional logic and finite state machine. That system decides what action to take. Finally, it triggers pre-saved motion files that make the robot walk or pick up an object. Now, the robot does not follow commands. It reacts to what it sees. To measure performance, I created real interaction tests. If I picked up one object, the robot had to select another. At first, it hesitated. After refinement, the robot started behaving like a teammate. It adapted, it waited, it adjusted in real time. At that point, I knew phase 2 was complete. This project completely changed how I see everything. Many projects focus on speed and performance, but in dangerous environment, reliability is everything. Now, whenever I design something, I ask myself one question: what happens if it fails? Now I am moving into phase 3. Phase 3 is fully about full independence. In this phase, the robot will perform complete task sequence on its own. The goal is still the same. Let humans stay safe, let the machine take the risk. Now, I am building phase 3 to turn the goal into a real-world reality. The project changed the way I think and adapt. Earlier, whenever I got an error, I used to stop immediately. I would feel stuck and not to know what to do next. This project gave me many challenges. Some were confusing and frustrating at first, but each time I worked through a problem and solved it, I improved a little more over time.